The catalog managers are another feature that is truly new. We had catalog managers in Apex, and we liked the concept, and customers liked the concept, and we liked the efficiency of unifying that between the two products. So we did. And we have catalog managers for light sources, lenses, refractive index settings about media, coatings, scatter models, functions, and variables. And the functions and variables ones are actually new, but really useful. And we'll talk more in context about what that's for. I use variables a lot. I use functions a lot. So I'm enthusiastic about having those in catalogs. And these can be used from any of the user interfaces to input data. Let's talk about light sources. The Light Source Manager has a number of catalog source types. For instance, if we have a LumaLED's LED that we want to include in a model, we can open up, we can actually browse the list. If we know the model number, we can type some of it in the search bar, and it will actually restrict our view to just the ones that match. If we don't select a specific class, we can still search for a source by its name or model number, and it will find matches even across different kinds of sources or different manufacturers if it happens to have similarities in the name. So, for example, we select this LED, took the very first one in the list, and we try to insert it. It actually asks us information about how we want to configure it. Like, do we want to run monochromatically or at multiple wavelengths? If we want to do multiple wavelengths, what wavelengths do we want? If we want to create fixed intervals, we can actually create a bunch of sources in a hurry, or basically create source models for a large number of wavelengths by just giving it the number of wavelengths in the interval across, in this case it's user defined, but we would give it an upper and lower limit, an interval and a number of wavelengths, and let it do its thing. That's one example of how we might configure. After we do this, it actually creates ray sets to represent the spectrum at the wavelengths that we have chosen as samples. And once those have been created, we can then attach those ray sets to the model. We can choose to model a number of wavelengths at once. We can choose to model a single wavelength initially for debugging our model and then add other wavelengths later. We have many options here. This just shows the dialog for attaching the actual data to the model. And when we're done, we actually see the sources pop into our viewer. So we pre-calculate the rays so that they don't have to be done dynamically every time. The process for creating a source when we start with it for the first time is we actually create ray sets, and that's where we choose the options for the wavelengths at which we model. ASAP models sources at discrete wavelengths. We don't have like a continuous spectrum model, but you can make the spectrum essentially as dense as you like, as long as you keep the number of sources below a system maximum. And you can always do a nonlinear analysis by doing a spectral band and then adding another spectral band in a series of analyses. And we can graphically choose the wavelengths when we have the spectrum showing in a case like this, or we can type them in. This is how we attach them, as I mentioned before. This is what it actually looks like when we browse to attach. It shows the files that were created, and we get to choose how they are named when they are created. They are named based on the source type name and the wavelength for each source. We attach them, and we get our model. So that broke it down in a little more steps. So with lenses, we also have a catalog of stock catalog lenses, and we can also build a custom singlet using the catalog manager. So if you have a singlet lens with specific characteristics that you want to build, we have a little builder for doing that, and you can add it to the catalog and then reuse it as much as you like. I'm just going to go over the remaining catalogs very quickly, because in practice, we'll see the details. And you probably don't need to know every detail to get your job done. I just want you to kind of know the general. Refractive indices. You can choose a glass by its name in a catalog. If you don't know a lot about glasses, you could, for instance, go into the catalog and say, my manager told me to use a shot glass, and I think I need a dense flint glass. And then you could just browse the list and see what refractive index and ABA number are each glass and say, this is the one I need. So you can shop for a glass here by working through the catalog, or if you know the name, you can just look it up by searching. If you need a glass that isn't in the catalog, but it's similar to a commercial glass, you can make a copy. You cannot edit the original, so don't worry. We have not allowed you to overwrite the data. So unless you go into the database where this is stored using another tool, you can't change these data. You can make a copy of the NBK7 data, and there's a copy button at the bottom that allows you to make a copy of something. It goes into your personal catalog, and then you can do as you like with it. So to go back to this, if we have a fit for a glass where the Sellmeier dispersion formula coefficients are a little different from the catalog, then we can actually go in and edit those Sellmeier coefficients. Or if if internal transmittance is a little different, or we have some extra data in a certain wavelength range, then we can actually go in and edit that as well in our copy, but we never have to worry about destroying the original. We can create new formula media from scratch if we have our own special formulation. Like I used to make custom plastics. I could actually measure the dispersion, fit it to one of a number of dispersion models. I know we have Conradi, the Old Shot, Sellmeier, I believe we have Cauchy, a few others. I can actually fit to the form and put the coefficients here. I can measure the internal transmittance and put that data in. And in the case of simple tabulated data, I can input a new material by just the real part of refractive index, by the real and imaginary parts, or by absorption coefficient. We also have coatings, and the coatings are organized by coatings that are layer descriptions, where it's a stratified coating design, coatings by a table of wavelengths and coefficients, ideal coatings, and these are useful for starting models when we don't know what the coatings are going to be yet, but we have examples of absorbing, reflecting, transmitting, and beam splitters. Those are very useful for initial layout. Notice in the layers, there aren't a huge number of coatings, but you can copy these and modify them as you like. And we have a few that are just kind of classic coatings. Creating a new prescriptive coating, we give it a name. We then put the media and thickness sequence as we go from the rare side to the dense side of the interface, and it automatically stacks them in that order. We can do it by wavelength, reflectance, transmittance, and it automatically assumes that the absorbance is the difference that makes the energy balance correct. So if the reflectance and transmittance sum to 1, then there will be no absorbance. We can also digitize data if we have a curve and use that to input to this table.